Good morning, everyone. I'm Yashasar. Today I'll be talking about the topic singly linked list. What is singly linked list? A singly linked list is a data structure where each element points to the next element in the sequence. Singly linked lists are commonly used in programming for their efficient insertion and deletion operations. The first element in a singly linked list is called the head. I'll be explaining more about insertion and deletion in my further slides. Here in the image, we can see node 4, the node 1, which says 4, is the head node. A linked list is formed from many nodes linked through the next point. The first node is also known as the head node. The last element will have the next property pointing at null. The node 4 is the last null, is the last node. Traversing in singly linked list. Traversing a linked list involves starting from the head node and following the next pointers until reaching the end of the list. Searching for a specific element in a linked list requires traversing the list and comparing each node's data with the target element. Linked lists have a linear time complexity for search operations. Here, when I will be traveling through the list, I will be checking each node, and when I get a suitable node, I will stop at that time. Insertion. Inserting an element at the beginning of a singly linked list involves updating the head of the point to the new element. Inserting an element at the end of a singly linked list requires traversing the list to find the last element and updating its in reference to the new element. Inserting an element in the middle of a singly linked list involves updating the reference of the adjacent elements. Deletion. Deleting an element from a singly linked list requires updating the reference of the previous element to skip the delete element. Deleting the head of a singly linked list involves updating the head to point to the next element. Deleting the last element of a singly linked list requires traversing the list to find the second to last element and updating its reference. The further slides the further slides will be explained by my teammate Sanya.
So, good morning everyone. I am Sanya and I will be explaining the other operations. So, we will go through reversing a singly linked list. A singly linked list can be easily reversed by changing the direction of the pointers for each node. Reversing a linked list in place involves iterating through the list and adjusting the pointers accordingly. Reversing a list recursively can be achieved by swapping the pointers in a bottom up manner. So what we will do here is we will just change the head pointer and null pointer, and thus the entire linked list will get reversed. So going to the next slide, applications of a single linked list. Linked lists are used in various data structures like stacks, queues, and hash tables. Stacks and queues can be implemented using singly linked lists to facilitate push, pop, enqueue, and dequeue operations. Hash tables often use linked lists to handle collisions when multiple elements map to the same index. Importance of a single linked list. Single linked lists are versatile data structures that can be adapted to various problem solving scenarios. Single linked lists are efficient for dynamic data structures that require frequent insertion and deletion operations. Single linked lists are a building block for more complex data structures like trees and graphs. That means trees and graphs can be implemented using single linked lists. It's the most basic data structure which can help make more advanced data structures. Here are a few drawbacks of single linked list. Complex implementation, difficult to share data and not suited for small data set. So complex implementation means the linked list implementation is more complex when compared to array. It requires a complex programming understanding, difficult to share data. This is because it is not possible to directly access the memory address of an element in a linked list. Not suited for small data set. Cannot provide any significant benefits on small data set compared to that of an array. There's also another drawback where in a singly linked list we can only move forward. We cannot move backward. That means backward traversing is not possible. So we will see the conclusion. In conclusion, singly linked lists offer a flexible and efficient way to manage sequential data in programming. Understanding the principles of singly linked lists is essential for mastering data structures and algorithms. By leveraging the strengths of singly linked lists, developers can optimize the performance of their applications and solve complex problems effectively. So, thank you everyone. This was our presentation on our single linked list.